Hello and welcome back to another video on number patterns grade 10. So this is just a continuation from the previous video that I had already posted. So I did mention that we are looking at patterns, and then to be specific, in grade 10 we are looking at arithmetic patterns. Those are types of sequences or patterns that are defined by a common difference. So we are just going to look at one or two questions that actually do come in grade 10. So we'll just take a look at them and how to approach them. So as the first example, we'll just quickly look at question number 4 right there. Given the sequence 2, 5, 8, 11, this is almost similar to the question that we did as an example in the previous video. So we'll look at question number 4 and question number 5. So just quickly, let me copy down the sequence and then we can start answering. So given the sequence 2, 5, 8, 11. Right. Then question 4.1, we are required to determine the general term of the number pattern. Right. Again, because all the patterns are still linear or arithmetic, the first thing that we need is to find D, and we know that D is found by a term subtracting the term before. Right, you only need to do this once. You don't have to prove it like in the previous video. That was just for definitely proving to say the common difference is -3. So in this case, our term 2 is 5. We subtract term 1, which is 2, and then we get just a 3. Right, you will notice also that I don't use a formula, but I am actually trying to get to the formula. That's what we do in grade 10. We are not allowed to use a formula, but we are trying to get to the formula. Like in the previous video, we are going to link a term number with its value to get the formula. So we have term 1, we have term 2, we have term 3, and so forth. Right, so using the terms again, the first term is a 2. How did we get this 2? We always take the common difference, we multiply it by the position, which is 1, and then all we need to do is balance the equation. Right, so the left hand side is a 2, the right hand side is a 3. What do we need to add or subtract from the right hand side to give us a 2? So to get a 2, this side we have a 3, it means we need to add a -1. And then again, once you have figured it out once, all you just need to do it 2 times, and then the third time you write the formula. And then let's check the second term, which is a 5. And then if we have a 5, we still use the common difference 3, but the position this time is 2 plus. So 3 times 2 is a 6. What do we need to get to do to a 6 to get a 5? We subtract a 1. Therefore, it means that in general, to get any position, which we call Tn, what we need to do, take a common difference, 3, multiply it by the position, and then a positive times a negative, that gives you a negative. And then the first question was calculate the general term of the pattern. Therefore, our general term would be 3n minus 1, or rather Tn equals 3n minus 1. Just like that, we are done, and then that would be a question for 2 marks. Right, and then the second question would be determine the 250th term. Right, 4.2, determine T250. So in this case, we are given the position, it is 250. We want to find T250. In this case, that would be our Tn. Right. So now in order for us to be able to do that, it's a simple substitution question. We know the general term, we found it to be Tn is 3n minus 1. Then we'll just have, wherever we see n, we put 250. So it's a matter of substitution. So we'll have 3 times 250 subtract 1. Then our answer to this question would be very, very easy. We'll have 3 times 250 giving us 750 minus 1. And then we'd find that 750 minus 1, this is 749. Therefore, T250 is simply 749. 4.2 would be done just like that. Then let's look at 4.3. Which term is 302? Which term is 302? 4.3. Which term is 342? Therefore, it means our Tn in this case is 302. Then we are looking for n, because n stands for the term number. Again, using the same general term, Tn is equals to 3n minus 1. We just substitute. Let's find the link. Tn is 302. Then we substitute 302 to give us 3. The n we don't know, we leave it as is, minus 1. Again, from inverse operation, we're trying to get rid of this negative 1. If you take it over, they like to say transpose becomes positive. So we'll have 302 plus 1, which gives us 3n. We'd find that 302 plus 1 gives us 303. This is supposed to be 3n. Then the relationship between 3 and n is such that these two are multiplied together. Therefore, the inverse of multiplication is division. So we have to divide by 3 because we want n alone. But whatever you do on one side, you need to do on the other side. And then if you take your 303 divided by 2, you find that your position is simply 101, which will correspond to n. Therefore, it means position 101 will give us a value of 302. Then that concludes question number 4. Then question number 5, again, the following is an arithmetic sequence. Arithmetic simply means a linear number pattern. Right, again, we're still using the definition, the concepts, to say a linear number pattern is defined by a constant difference or a common difference. In this case, we are given the pattern 1 minus p as the first term. Then we have 2p minus 3 as the second term. We have p plus 5 as the next term. First question, calculate the value of p. This is for 3 marks. Right, in order for us to calculate the value of p, we are going to use the concept of the common difference. And we know that the common difference is found by taking a term, you're subtracting the term before. The answer that you will get there is also going to be the same as taking a term, subtracting a term before. So in this case, we can just say the difference. We know that if you take term 3, you subtract term 2, the answer that you get there should be the same as taking term 2 and subtracting term 1. So in this case, again, we have term 1, we have term 2, we have term 3. But this time around, these are given as expressions. So we need to use these expressions to find the value of p. Right, let's substitute. What is term 3? Term 3 is 2p minus 3 minus, then now when you substitute the binomial, you always use brackets. 1 minus a p. This gives us term 2, which is 2p. Or rather, is 2p. Wait. This is supposed to be p plus 5 minus 2p minus 3. Yes, be careful every time you make a substitution so that you avoid making such a mistake. Then our term 2 is 2p minus 3. This time around we subtract term 1, which is 1 minus a p. Right, then once we have this, we're trying to eliminate the brackets by multiplication. So we'll have p plus 5 as the first term. Negative times a positive will give us a negative. And then the invisible 1 times a 2p, this gives us 2p. Then this negative times this negative will give us a positive. And then this 1 times 3 will give us a 3. Then we do the same to the other side. We'll have 2p minus 3. And then the negative times a positive will give us a negative 1. Then a negative with a negative will give us a positive p. Then this has formed a type of a pattern, which is a linear pattern, or rather a linear sequence equation. So for a linear equation, I would like to say all the terms with the variable, you keep them on one side, and then you collect everything else, which are your constants, on the other side of the equal sign. Right. Having said that, we are going to have the following. Collect all our p's on one side. This p stays with this 2p. Then when we transpose this other 2p to the side, we have a negative 2p. And then when we bring this p over to the side, we have a negative p. And then we get to the other side, we already have this negative 3 right here, joined by this negative 1. And then this 5, when it joins this other side, will have a negative 5. And then this 3, when it goes to the other side, it becomes a negative 3. So we group all the terms with a p on one side, which are our variables in this case, and also the constants on one side. Then let's do the mathematics. We see that we have a p, we have a negative p here. So these two p's, they cancel because they're exactly the same, but opposite signs. Then we'll have negative 2p, negative 2p. Again, we treat these as integers. Integers with the same sign, you keep the same sign, and then you add the integers. Then you'll have 2 plus 2, you get a 4p. Then we go to the negative side, or to the other side. We'll have a negative 3, negative 3, negative 1. So we see that all the signs in the other side are negative. So we'll keep the sign, same sign, and then we add. So we'll have 3 plus 1, which is 4, plus 5, which is 9, plus 3, and then that will give us a 12. Therefore, in this case, we can now solve for p by dividing both sides by negative 4, because we want a p to be negative, to be positive. Negative 4. Remember, everything you do on one side, you'd also do on the other side, just to balance the equation. Then negative divided by negative is a positive. 4 divided by 4, you are left with your p. And then this side, negative divided by negative is positive. And then 12 divided by 4, you find 3. And then we have answered the question to say we have found the value of p. Right, 5.2.1, determine the first term of the sequence. So the first term of the sequence, 5.2.1, we are looking for T1. And from the equation, we were told that T1 is given by 1 minus P. But we know that P is a 3. So to get our term 1, which is our first term, we'll just substitute 1 minus a 3. And then 1 minus a 3, this will give us definitely a negative 2. This will give us a negative 2. Therefore, we are done with the first question of 5.2. Let's look at 5.2.2. It is requiring us to determine the common difference. So the common difference, we have already found an expression for the common difference. We said this is T3 minus T2, which is the same as T2 minus T1. But now, one easy way, already we know what T1 is. We can quickly find T2. So T2 also given by 2p minus 3. We can simply have the following to say we'll have 2, our p being a 3, minus a 3 to give us a 6, minus a 3, which gives us a 3. Therefore, we can just write down the first two terms, T1 and T2, and then use this to find our common difference. T1 being a negative 2 and T2 being a 3. And then our D would simply be T2 subtract T1, which will give us 3 minus a negative 2. As previously shown, This will give us a3 plus a2, which will give us a5. Therefore, it means our common difference in this case will be a 5. This wraps up our second video on number patterns, grade 10. Please stay tuned for more, as I will be recording a few more videos explaining some other topics related to grade 10 mathematics. Thank you so much for watching. Please subscribe and share. Like the video. If you have any questions, please feel free to post them on the comment section. I'll be here to wait from you. Thank you. Bye.